Okay, great. All right, thank you everyone for coming out here on the last day of the conference, and welcome to the talk, Linux-based web app development made easy on app service with your host, me, Stefan Shakow, one of the many folks who works on Azure App Service. So, just to give you a quick overview of what I'm going to talk to all of you about here today, I'm going to walk through in general how you push code up onto the Linux variation of App Service and slipstream into some of the new things we've introduced over the last couple of weeks. Then we'll switch gears a bit, talk a little bit about App Service Managed Certificates, just so that you folks are all aware of it. It's available actually for both Linux and Windows, but this is a good place to cover it. Give you a quick update on the State of the Union for virtual network integration on Linux, and then we'll round out the session with a deep dive on the new log analytics integration, and specifically with a focus on using it on the Linux side of our product. So just to sort of get things going, I am going to jump over to demo machine, just because there's some stuff there that I sort of want to go through to level set the basics of how you get code up and running on Linux App Service, and then also just touch on a few other points that we've introduced into the service in the last few months. So given just the interest of time, right before the session, I took a Node.js React app, made a couple of changes here on my laptop, which happens to be a Windows laptop up here on the podium, and then I did a git push and pushed it up to App Service, and then I just wanted to show you just, hey, there you can see at the end it tells us that it went ahead and did the push in about 90 seconds, and so I've done this a few times, typically varies between about 1.5 minutes and 2 minutes. Reason why it's an interesting just sort of scenario to touch on is that when you go out and look at a Node.js React app on your laptop, you'll see it probably has somewhere in the vicinity of 27,000 individual files. And up until probably about 6 months or so ago, it was actually somewhere between difficult and impossible to go out and try to deploy and run that kind of workload on App Service. So I'd like to start out with showing that just to sort of reinforce that a lot of the improvements we've made on Linux App Service have been around making it possible to take these kinds of open source frameworks that may have very large quantities of files, and we are able to actually ingest them and build them efficiently. Another thing, not directly related to build, but I just, the build system, but that I wanted to touch on, just to make sure sort of folks are aware of it. Not too long ago, this is probably about late summer, on the Linux variation of App Service, we made some changes to the way we set up the pricing for our different SKUs. And so, again, if you may not have noticed it, just wanted to call it out for you here. This is an app, the one we were just looking at, running on Linux. And you can see here, I've got it running on the P1v2 tier. And if you compare and contrast that with the pricing down here of the standard tier, you'll notice that it's a heck of a lot less expensive than most of the standard tier, and it's probably all of about like a $10 a month difference compared to the S1 tier. So the reason why I wanted to call that out is, again, we didn't actually make like any formal announcement because it sort of rolled out in phases. But if you've looked at our service before, or even if you're running on it today, we definitely recommend you run on the PV2 tier. We think it's a much more powerful, much more cost-effective option. And if you're already running on us today, when you get back to work, you might want to take a look because the entirety of Linux App Service supports PV2, and you may very well be able to just shift over to the premium tier, end up paying less or not very much more, and have a much better experience. The other thing I wanted to touch on briefly is down in the dev test pricing tiers. Similarly, if you take a look, not only do we have the free tier that we introduced about 6 months ago, but we also substantially reduced the pricing on the basic tier. So if you have things that are not necessarily production workloads, if you just have things running in the background, or you're kicking around with some proofs of concept, things like that, it doesn't cost a whole heck of a lot to throw a couple of those apps onto a B1 worker on the Linux tier and just have them running off there in the background. All right, so like I said, I just wanted to make sure we touched on that, sort of reinforce that with folks. Jump on back to the slides, and let's talk a little bit about what's actually involved with the built-in build system that we have in App Service. So what I just showed you was sort of an example here I've got up on the slide of doing a local git push from my laptop up onto the worker that's running an App Service where we actually have a miniaturized build system that does whatever building means for the individual frameworks. And so in the example of Node, for the most part, it means running npm install. For Python, it means looking at requirements txt and doing a pip install, things like that. And so we have support for a lot of different ways of going from code that may be sitting in GitHub or a repo, any number of them, being able to get it into app service where we can then build it, and then the end result is you have a runnable app. Now the second option for getting code up and running on app service is being able to give us the compiled artifacts. Now for purposes of Linux app service, it's only the war, jar, and zip file options that are relevant because of course web deploy is, that's pretty much a Windows only solution. But the specific thing I wanted to touch on today is we've been working over the last few months to start integrating with a capability over in GitHub called GitHub Actions. And GitHub Actions, they've actually had, I think, one version, and now they've got a newer version that's been in preview for a while. It is a way to structure a workflow in YAML that does stuff, including, of course, building your app over on GitHub. And then from there, what we've done is we've worked with the Actions framework over in GitHub to then be able to deploy the results over onto app service. So let's take a look at that. For starters, what I'm going to do is first just kick off live a GitHub workflow. So in this case, I happen to be in a repo out on GitHub, and it's a Python app, so I'm just going to make a small change here so that it makes it clear that, yep, we're actually doing a live change. So I just change a little bit of text. This should trigger the workflow that's over in GitHub Actions. And probably, again, it might take around 90 seconds or so to run in the background. So I've kicked that off, and while that's chugging along in the background, let's do a brief walkthrough of what using GitHub Actions looks like. So this is an example repo. This happens to be for a Node app. And in the world of GitHub, if you have this folder, GitHub Workflows, and then if you have a YAML file inside of it, this is where you can define what you want to do with GitHub Actions. And so for the most part, the syntax, I'm not going to go deeply into it, but I'm going to focus on the part that's sort of specific to Azure, but it's got the normal things you'd expect, right? There's some way to trigger running the workflow. So in this case, right, I just went out and pushed something directly into my master branch. You tell GitHub some setup, what do you actually want to use for a build server underneath the hood? And then you start making use of GitHub's actions. And you can see here the syntax actions/something, and then optionally you can go out and specify some kind of a version identifier. Because underneath the hood, actions up on GitHub is actually code running over in GitHub, and of course that functionality will change over time, so it's good to be able to have some kind of a versioning story where you can get the guarantee you're using the version of the action you want, and yet us and other software companies that integrate with GitHub can continue to iterate and update our functionality over time. So again, here, since this is sort of a good example just for like a Node app, we're basically saying, great, hey GitHub, go do some setup so I can go out and build Node. And then the core of it is pretty familiar, right? Go out, do an install, and then if there are builds and tests, you can go out and do that. But basically expand out the packages. So at this point, basically when you get done with this step here in the GitHub build universe, you're still over in GitHub. You've got a bunch of stuff sitting on some build server somewhere, and we're over here in app service. So how do we get from point A to point B? And this is pretty cool because now what we get is we can go into an actions namespace called Azure, and in the case of app service specifically, there's an action called web apps deploy. And we're not the only Azure team that integrates with GitHub Actions. So if you look out there online, there are similar actions that exist, for example, with deploying containers over to AKS, and then again, over time, other services in Azure. So in our case, right, since we're app service, we're saying, great, why don't we go take those compiled artifacts sitting on the GitHub build server and go deploy them over to Azure App Service. So the syntax here is telling us, here's the name of the app I'd like you to deploy it to. And then there's just this action syntax that says, okay, by the way, here's some information that'll tell you how to get there. Now underneath the hood, this secrets publish profile, that is what's called a GitHub secret. So if I jump over here and just show you an example, if you have GitHub Actions set up on your account, you'll have an option when you click into it to set up secrets. You can't actually see a secret once you've created it, but what we did is we created a secret with a given name. And, you can call it whatever, chocolate, blueberry, doesn't matter. But the value of this secret is the actual XML of the publishing profile that you download from App Service. So popping back here to the Node app, this secrets.publish profile, that's the name of the secret, and the value is actually the raw XML you would get if you, for example, you went into the portal and downloaded the publish profile. And that's how the action code running underneath the hood on the GitHub build servers is able to connect to us. Because if you've ever looked at a publish profile, it's got a username, it's got a password, it's got a publishing endpoint. It has everything a program needs to know where to go and how to authenticate and then basically push the code over. So let's pop back here to the Python app that I kicked off. Let's take a look at the actions, and you can see, okay, there's the one that just kicked off. It was 4 minutes ago. It said it took 1 minute and 4 seconds. And what's nice, again, if you happen to have used pipelines, because that's sort of the inevitable comparison, there's a certain amount of familiarity. You can click in, you can see logs of what was going on. If you look in here specifically, and if you know sort of how underneath the hood publishing works in the app service universe, you can actually see the log here where it's calling the SCM endpoint, and specifically it's calling zip deploy on our APIs. So literally underneath the hood, that action is just zipping up the compiled artifacts and saying, here you go, app service, zip deploy, go do the right thing. Now, some cautionary notes. This is all pretty much still in preview, and the reason why I'm sort of jumping around between Node and Python is if you build a workflow with GitHub Actions with Node, it will actually check out the code and build it over on GitHub and then just push the packages over to us. It's all, all good to go. Python's a little bit different. We're still actually struggling with how to get it to run smoothly, and somewhat jokingly here, you can see there's a bunch of green, then you see you see a failure, you see more failures, and literally over the last few weeks we've been flipping back and forth trying to figure out how to sort of nail down the Python flow for GitHub Actions. But for now, if you take a look at how it runs, it's actually a stripped down version of what we saw with Node. So this is the workflow that we set up for the Python app. And the starting point is pretty much the same, right? Get me an Ubuntu server, go out and do the checkout, set up things for Python, but then you notice we don't actually build anything. We just turn around and say, here, go push literally the source code that's sitting on a disk somewhere on a GitHub build server over to us. And the reason for that is, right, if you've used Python, there's this concept of virtual environments, and we're sort of struggling with the fact that you go build it on this build server, and unfortunately the environments and the file paths don't match up with the virtual environment and the file paths on the app service side of the house. But you still can get benefits from it because you can still kick off the build of your repo over on GitHub, just push us the code by just using the deploy option, and then if I come over here and drill into the actual Python app that I'm going to, what we did is we set an application setting on the app service side of the house, and it's this one I have highlighted right here. This SCM do build during deployment is set to true. And so what that means is the GitHub action pushes us all the source code in a zip file and says, here you go, app service. And then we see this app setting is set to true, and we're like, okay, we'll now use our build server to actually, for example, pip install everything inside of requirements.txt. And the nice side effect is the issue with file paths and virtual environments, at least since the build is happening in our universe, everything is sort of set up properly. So again, I wanted to call that out because Node works cleanly. Python, you have this little hiccup. Of course, we'll keep on working on it, but just if you play around with it for now, just be aware those are the steps you want to go through. And then just to prove that, yes, that build went through. So there we go. I just pulled up my Django app, and you can see there are the changes I made live a few minutes ago in my repo. So I was able to literally just sit here, make a one-line change, do a commit, and then the push, the build, and we're back up and running over here on app service. So pretty cool stuff. All right, I'm going to jump back over to the deck, and we will talk about sort of the next way that you get code up and running on Linux App Service, and that's using containers. So App Service itself, from day zero, started out with the idea of you give us source code, and we'll go out and build it. And then over time, right, when things like Azure Pipelines came along or Azure DevOps, the idea of give us the compiled artifacts and we'll go run it. And then when we built out the Linux side of App Service, not surprisingly, underneath the hood, we ourselves are running containers all over the place because literally that's how the service is implemented. And so we also support you, the developer, giving us a container and telling us to go run it. And just like sort of any other container environment, it's the same name of the game, right? You point us at a container registry, give us a reference to the registry, to the actual container image in the tag, we'll pull it down and run it. So what's new about that is we've also done the work so that you can do the same process, but having the build and the Docker push happening over in GitHub using a GitHub action. So again, pop back over to the demo box, and let's go take a look at what that looks like. So right now, in the browser, I'm parked on another repo that has a Java application. I think it's one of the sample Spring Boot apps that are out there. And you can see, right, I've got a Docker file and then everything else that makes up my Java app. And what I did, again, probably about 2 hours ago is I made a simple change inside of the repo to kick off the workflow. So let's actually take a look at what this workflow is doing, what this GitHub action flow is doing. So again, we start out here, we say, hey, what should actually trigger this specific workflow? And you notice here we've actually said, hey, don't go run it on the master branch, go run it on this different branch. So again, it's one of those nice things about GitHub Actions. You can actually have different flows for different branches, different triggers. It's a nice syntax, very flexible. So again, we'll go out and run on a Linux machine. We'll go out and we'll do a checkout. So far, so good. So the first thing is, okay, this is a Java app, so GitHub Actions supports running Maven on their build infrastructure. So this is the command that's actually over there on the GitHub server saying, great, Maven, go do a build. And now we switch gears into how do we actually integrate everything with Azure. So there are a couple of things going on here. We have an action that's specifically about allowing the build process on GitHub to basically do an AAD login against Azure. And you can probably get that vibe because you see here we called it SPN. So literally, earlier we went out and created a service principal using the Azure CLI, took that SPN and stored it as a secret over in GitHub. And the second thing we did is we built an action that also lets you log in against Docker Hub. And so again, now I've got two sets of values here. It's the username and the password that's necessary for GitHub to authenticate to Docker Hub. So why is that, right? Why do we have two sets of creds, right? Let's think about it. I've got GitHub, it's build infrastructure, it's got a build, it's now sitting on its disk. What does it need to do? It needs to somehow authenticate to GitHub to be able to do the Docker push, because you got to get, right, the Docker file from the build machine to the container registry. But then, given the way Linux App Service works, GitHub needs to turn around and call us up and say, hey, App Service, there's a new version of the container, you should go pull it. And in the world of Linux App Service, that's actually a property in Azure Resource Manager on your site object. If you actually take a look like in Resource Explorer, you'll actually see literally there's a property that's something like Linux FX version, and it's got this long string that is literally the reference to your container. So that's why this workflow needs two different sets of credentials to authenticate. So with that in mind, we're on the build server again in GitHub. It goes out and does a Docker build, and I'm telling it, you know, hey, here you go. There's the reference you should go use for the container you create in Docker Hub. And you can see for the tag, it's just generating a SHA based off of the build artifacts. And then we go out and we do the push. And so by the time this step runs, I've now successfully pushed the container with my newly compiled Java app over to Docker Hub. And then the last part of the puzzle is, once again, with an action specific for Azure App Service, but in this case, it's a container deployment action. We are telling GitHub, here's the name of the app, and by the way, here's the value that you should actually be putting into the property over on the site object in App Service that tells us to go pull down the new container. And if we pop over here into the Actions UX and take a look, you can see again earlier this morning before the talk, I intentionally kicked off a build. And then we'll scroll down a little bit here into the logs, and you can see, the nice steps, right? We've got the Maven build, we have the successful Docker build and Docker push, and then if we drill in specifically to what's going on here in the part where it talks to app service itself, you can see like here's the patch command that it's issuing, and right above it you can see that's actually the property, Linux FX version, Docker, and then with the whole container reference. So that is actually the log output showing you that the GitHub build infrastructure is using that SPN to literally call into ARM over an app service and say, hey, app service, you've got a new container reference. And then the final chain there is when that property changes on our service, we go through and we say, okay, let's go ahead, let's pull down the new container and pull it into app service. And then again, just to prove that, yep, sure, it actually ran, we'll click in there it is, it's running. Trust me, that's the text that we went ahead and put in there, and right, this is the little common to-do list sample app that they have there for the Java Spring apps. So that's what I wanted to run through with you here, just in terms of like sort of the baseline of what's involved with getting source code pushed and built over on app service, and then showed you Node, Python, and Java, right? Node and Python were source code. Java, I just happened to pick Docker container. You could just as easily do a Maven build and just push the build artifacts to us, but it's all wired up and running through GitHub Actions. I know it's a lot to sort of throw at folks, but there's an app service blog that we have over on GitHub.io. It's got a lot of great info in it. For this case specifically, we updated this blog article, and it's got literally all of the CLI steps and YAML samples, so that if you're wondering, like, how do I get the SPN that I just saw, this is an example of how you can go do it, and then a full example of the actual YAML syntax. So we've got it updated here for Java, Node, Python, and .NET Core. And then sort of looking ahead to the future, we're not there yet today, but if you've used App Service, you know that you can go into this feature called Deployment Center, and you can say, hey, go connect my app to a GitHub repo. So as it exists today, that's still pulling from GitHub and doing the build inside of App Service. Probably not surprisingly, with what I've just showed you here today, somewhere in the future, we will probably want to start building that out so that instead the GitHub repo integration, at least in Linux App Service, switches over by default to instead relying on GitHub Actions, because then that way they've got a much richer universe that they can go invest in terms of, like I said, what you can do in the YAML workflows and all the different kind of build functionality that they can build out on the GitHub side of the house. So like I said, take a look at this blog. As we get more info, we'll keep it updated, and also just keep a lookout in the future as we make changes on the service. All right, pop on back to the deck real quick. So next, just switching gears a bit, I wanted to take a few minutes to talk about the App Service Managed Certificate offering. And so that's an offering that gives you no cost TLS security on your apps. It's actually available for the entirety of App Service. It's there for Linux, it's there for Windows, it's also there for Functions, because all three of those services share basically the same underlying infrastructure. The deal is you get a cert, you don't need to pay us anything for it. You can go ahead and associate it with any of your host names. The one thing is it does have to be a full host name. We currently don't support the Apex domains, and if anyone's given us feedback, thank you, we've heard it very loud and clear at the conference, so it's definitely something under active discussion internally. But for now, you do have to have a full host name, a full custom domain. We do support binding multiple certificates to your app. So if your app has, say, 15 different host names associated with it, you can actually get 15 free certificates, one for each host name, and bind every single one of them. So it's not a wildcard cert, but you can still get multiple certs for multiple host names. And the one thing that we do have currently, it's in progress, is the TXT validation. I wanted to call it out here, because if you do make use of this, currently it uses CNAME validation to verify that the domain name that's being issued for the cert actually points at the underlying Azure Websites.net host name. And that's actually part of the reason why, for example, Apex Domains isn't in the initial preview because, right, if, for example, you've used any of the other cert authentication that we have, you know you need to do something like TXT validation or maybe even email validation to be able to verify a root domain, because there's no such thing as a CNAME for a root domain. So I'm not going to go through the issuance process live, just because, again, it takes a little bit of time. I already set up an app ahead of time with one of these certs. When I did it, it took me, it was somewhere, again, a little bit more than 90 seconds from the time I punched the create button to me actually getting the cert. So first off, let's just pull it up with the custom domain in the browser. So assuming I remember this correctly, okay, great, I got the app. Let's click into the SSL info and let's go view it. So this is what a managed certificate looks like. So you've got a single host name. You can see the root CA is actually DigiCert. And if we take a look at the validity information, you'll notice, right, I created this cert a couple of weeks before this conference, and it's good for 6 months. So you get the cert, it's for a single host name, it has a 6-month validity period, and again, as part of the managed portion of this offering, about 60 days before that expiration date, assuming the certificate is still in use by you, we will go out and automatically issue a renewed certificate, and we will automatically rebind that new certificate in your SSL bindings. So assuming everything works, and again, it's a preview, so knock on wood, there might be some hiccups. The only thing you have to do is set this up once and bind it, and again, every 6 months it'll happily chug along, auto-renew, like I said, about 60 days before the expiry period, and you'll have a brand new cert constantly getting refreshed as the months pass by. In terms of how you would actually do it in the UX, if you come in here to TLS and SSL settings, and assuming you've already got the custom domain that you want to use with the cert set up, you come in here, sort of the same click path that we have for app service, and there's a new option off on the right-hand side called Create App Service Managed Cert. You click into it, you have an option to go ahead and select one of the host names that's associated with your app. Now in this case, of course, I can't go out and do a create because I already did it like 3 weeks ago, but you just click create, and then again, give it about 1.5 to 2 minutes. Assuming that that host name is CNAMEd to the Azure Websites.net app, you'll be the proud owner of a new managed certificate. And then the last thing you do is you pop over to your custom domains, and then you'd go out, you'd come back here to the TLS, and at the bottom there, you'd go out and select the binding. So you'd go out and pick the host name, there's the managed certificate, and then which SSL type you wanted, and you'd add it and bind it to your app. Which, right, as an aside, if you happen to have a custom IP SSL address for your app, you can go out and use this managed certificate as well on a host name that's bound to that IP SSL address. So you can use it for either SNI or IP SSL. And like I said, once you go through all of that, we will then happily renew the certificate automatically every couple of months and renew the binding, and you're good to go. So, hopefully that's useful, if nothing else, for like dev test scenarios, maybe even production apps where you can handle the lack of the TXT validation and can take a little bit of the downtime. And it certainly, from our perspective, seems to be pretty popular because when we were looking at the numbers last night, we're already past the 1,000 mark in terms of the number of certs that we've gone out and issued on this, and we've only went out and announced it like sometime Monday afternoon. So suffice it to say, we're pretty excited about it, have pretty high hopes. And to reiterate, it's available for the entirety of app service, both Linux and Windows, and you can also use it with your functions, because underneath the hood, functions uses the same infrastructure for setting up SSL. All right, so switching gears, next topic. I wanted just to give a very quick update on VNet integration, the State of the Union for Linux. I'm not going to go into super details about how virtual network integration works. Hopefully you saw the talk yesterday from one of the folks on our team, Christina. But basically, this is about how do you hook up the back end of your application running on Linux app service so it can actually connect to, for example, resources on the other end of an express route circuit. So it is still very much so in preview. And unlike the Windows side of the house, which hopefully, again, will GA before the end of the year, this is still in preview, and it will be as we move into the new year. What will be coming between now and the end of the year, though still in preview, is support for public IP address ranges in the VNet, because in essence, for the Linux side of the house, we get that for free, because that work goes on across both Windows and Linux. We'll get support for being able to shape the traffic that egresses out of the connected subnet, so that's the user-defined route table support. And then probably the most important one is we will get the necessary fixes in so that for the Linux side of app service, we will have support for the spoke hub architecture. Because again, I know from talking to a lot of you, whether it was here earlier on the hub floor or just again in various con calls back at work, right, it's very common that folks will put their app workloads and connect them into a spoke virtual network. They will peer it to a hub virtual network, and that's the one that's actually got the expensive express route circuit, or hopefully less expensive, site-to-site connection on-prem. So we will be lighting up support for that, again, before the end of the year for Linux. Just to show sort of how things look like, just to sort of prove that, yep, it's still there and working for what we've got running. For the heck of it, we set up a custom container. This is actually WordPress. First, just to prove that, yeah, great, the app works. But the main thing is, this is actually a custom container running WordPress, and we hooked up the back end to a virtual network. So if we scroll through here, we can see, yep, it's connected to a VNet, and it's connected to a subnet. So the back end traffic will go to that. And then similarly, we went over to the MySQL offering that is on the Azure database service. And we made use of service endpoints to lock down inbound traffic to this MySQL database. So you can see here we have turned off the ability to have anyone just willy-nilly connecting to this database, and instead we defined a virtual network rule that says only allow traffic if it's coming from the default subnet, which is the one I picked, that's inside of this test virtual network. And you can see that the service endpoint is enabled, and that's why the container running in Linux is able to get into the virtual network and then connect to the MySQL database. Now, one of the reasons why we still have the virtual network integration in preview is because if you happen to use a custom container on Linux App Service, you'll have to take a look at our docs, because there's a very important point. You have to modify your container so that somehow it will read this environment variable that we pass in on Docker run, and then you need to actually have your web app listening on that port. And the problem is that port is dynamic. So every time the container restarts, the port is some other random value. If we restart the VM, the port is some other random value. And so that's why it's pretty straightforward to use the VNet integration if you're deploying source code to Linux App Service, because we take care of all this for you. But if you brought your own custom container and you sort of hooked up the virtual network, you might have been frustrated because you're like, I'm looking at my Docker logs and it's telling me there's some error saying that we can't find the app on like the root URL, and then we basically throw our hands up. It's because this port variable probably wasn't picked up in your startup script in the container, and as a result, there's nothing for us to talk to. Now, the other reason why I call this out is one of the reasons why we're still in preview is we're literally re-implementing part of the virtual network feature on Linux with the goal of completely eliminating the need for this, because it's pretty obvious from the feedback and from folks using the feature that this is confusing and it's a stumbling block. So again, just to sort of give you some color on what's going on. All right, so that's virtual network integration. Let's pop into the last topic here in terms of what's new in the world of Linux App Service. So for quite a while, right, we've had rather, shall we say, minimal logging options on the Linux side of the service. We basically have some basic functionality that could log to the file system, and then other than that, it was sort of, shall we euphemistically say, left as an exercise to the reader. Luckily, we fixed that because, again, one of the announcements this week is that we rolled out preview support for integrating both Linux and Windows side of App Service with log analytics in Azure Monitor. And so this is a screenshot of what it actually looks like now if you set up the diagnostic settings for an app running on the Linux side of App Service. So I'll show you that live in a little bit. Let's just go over what you get. So at a high level, this is about being able to take textual log information that's in the App Service platform and being able to get it out of the platform into the Azure Monitor pipeline, where you can then do different things with it. So the first one is you can ship all this textual log information to different targets. So you can go out and persistently store things like request logs, console log output, you name it. You can store it in Azure storage. You can have it sent to event hubs, or you can pipe it into log analytics. And furthermore, you can do 1, 2, or all of these. So it's completely up to you to pick and choose what you want. You can actually send data to every single one of these data sinks. If you happen to send it to log analytics, which is what I'll show you here in a bit, it's very powerful. You can go out and write queries against the textual data, and you can create alerts against them. It's actually somewhat familiar to us on the team, because literally the log analytics functionality that you see lit up now looks like basically a developer-facing implementation of how we actually manage and query the log information internally that we generate to run the service. The other thing just to note, right, with the storage and event hubs, part of the reason those exist is targets where you can send your log data, is so that you can go out and use third-party tools. You know, maybe it's a Splunk, or maybe you use Elastic, hook it up to one of these two data sources, and then from there you can go out and leverage those services to go out and process, summarize, and query this data. So this is all the different kinds of information currently that, through a mix and match of either Windows or Linux, that we go out and log. I'm going to touch briefly today and show you the first one, which is the HTTP request log. So being able to get logs showing you that, oh, there was a GET request and a PUT and a POST, and how long did it take, and all kinds of that info. And then the names here that are in bold, those are the table names in log analytics that you can go out and reference and query. So on Linux, we have it wired up to standard out and standard error. So, you know, if you're, again, doing like console logging, very common on the Linux side of the house, you can stream those over here into that table and go query them. If you're on an app service environment, the ACE team has gone out and started streaming ACE events about what's going on with the underlying infrastructure into the corresponding table. The app service app logs table is a place that we're using to send sort of a well-formatted exception and error log information for specific languages. And I'll show you an example of what that looks like for Java on Linux, which is the one option that we have hooked up right now. And then the last two are about giving more auditing and visibility into what's going on inside of the platform. So you can actually see, for example, that someone authenticated to an FTP endpoint. Or down the road, we're building it out for Windows, you'll actually be able to see individual file access operations and get that logged. So this is just basically the state of the union. Long and the short of it is Linux has pretty much most of the log information already available. The biggies for Windows are the console logs, standard out, standard error, and then the file access logs that are still in progress being developed. So let's go out and take a look at this for a quick test drive. So what I did again earlier before the session is I ran a very simple load test against one of my apps just to generate some load on it so that we could query on it. This is the app. And just first off, in order to be able to set up integration with Azure Monitor Logs, you click on this new option called Diagnostic Settings, and then you can walk through and you can set up basically one or more settings that will tell the system where do you actually want to flow this data. So in my case, I've already set them up in a few places, but again, when you click into it, you can see options for sending data to storage, to Event Hub, to log analytics. Yutong, who presented on this back on Monday, mentioned that before you click in here, if you're going to do storage accounts or Event Hub, those already have to exist because this UX only lets you select the pre-existing resource. So just remember that. Otherwise, if you're like me, you'll click in, you'll be like, oh, I got to go create my storage account. And you sort of back out, do it, and then come back in. So just a little note on how the UX works. And then if you are doing storage event hubs, you can sit here and select the specific logs that you want to send, and you can also set retention policies. So once you've got that set up, what you can then do is you can then query on the information. Now, currently, quick note, if I want to query on my log data through log analytics, we're currently missing a log option in the UX that's inside of the app service UX, which is where I am right now. So this is what you do. If you set everything up and you generated some load and you're like, where the heck's my data? This is what you do. You go back in and you find the log analytics workspace that you created, because that will get created as an artifact. And then in here, there's an option to click in and say, okay, let's start querying my logs. So we'll give it a second to chug on through. It's going to go ahead and show me queries that have run previously, and then here on the left-hand side, I can basically go through the list of all of the different log sources that are available inside of Log Analytics. And this also probably gives you a little bit of an idea why we named everything app service and then something, 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 so that you can sort of scroll in here and say, okay, this is the part of this huge tree of tables that's relevant to app service. So if we just take app service logs, and just for simplicity initially, let's look at them for the last 4 hours and go query them, it should pull up and show me basically the results of the load test that I was running earlier. And so again, obviously we're not going to scroll through 110 pages of logs, but you see they're all my hits, right? I was doing a bunch of gets against the root. It tells me where it's coming from, what was the status code, all that kind of information. And it's scrolling off there on the side, but it'll also tell you how long each request took. And then what's cool is, like I said, once you sort of get familiar with it, you can go out and start querying and filtering the data. So I'm going to say, okay, let's look back over the last 3 hours. Since I was running the load test mainly against the root URL, let's just limit ourselves to that. And then let's go out and summarize. So we'll say summarize the hits. And I'm going to go out and bucketize it in 1-minute increments. And then let's see if we order by time generated descending, and we'll see whether or not I clicked everything correctly there. Okay, so that's a much nicer view. So I don't have 100 pages of information. Now it's showing me a nice bucketized list minute by minute of how many hits were going against my app. And again, in this view, I can actually scroll down a bit and see the chart of the hits that were coming through from my load test app. And again, since we're sort of zoomed in here, it doesn't look all that great, but you get the idea that you can see both tabular and graphical information. And again, as you get familiar with it, summarizing it is the most powerful thing, because again, I get folks asking and saying, hey, how do I get an alert if there's some spike in load on the platform? Well, guess what? This is how you do it. Right? And again, you can tweak it for the time frame and the URIs you want to look at and summarize more deeply, but this is how you pull it off. Now again, in the interest of time, I'm not going to walk through how you create an alert based on it, but what you can do, and what you can imagine I did earlier, is I created an alert using roughly that query, and you can actually see here in the alerts dashboard within the Log Analytics workspace, it's actually telling me that sure enough, something's been going on. I've been triggering this alert. So let's take a look. November 8th, 6 a.m. Well, that's because it's doing it off of Pacific time. But this is exactly when earlier this morning I was running the load test. And so you can see here, this is actually the query that drives the detection and the triggering of the alert. Again, I'm doing the summarization on that URI. And I'm saying, hey, look, if I get more than 100 hits, basically within a 1-minute time frame, and this has been going on 5 times within a 5-minute time frame, you should go out and fire an alert. So I can go out and see those alerts here in the UX, and if I pop off here to a different browser window, similarly, I set up the alert in this case to go out and email me. And so again, you can see here, there's the query that it's running. It's telling me how many times it got hits. And if I scroll down here on the bottom, it'll actually give me the top results, which is nice. If it's 2 a.m. in the morning and you're sort of bleary-eyed and looking at it, you can actually say, okay, hey, maybe this gives me some idea of what's going on. So the Log Analytics stuff also, they can go out and send it like SMS. It can go to a pager. They can fire the JSON information over to a webhook, so you can hook up to a third-party service or something you write yourself to consume that data. It's very powerful, and especially for the Linux side of the service, I'm really happy that we've got the hookup connected, because I think it fills in one of the last blanks there that we had on the service. One last thing, again, just so we're running low on time, I just wanted to show you what an alert looks like when it comes from the app service app logs. So this is the data source that contains nicely formatted information. Right now we've got it set up for Java. And specifically what's nice about it is that if I scroll down here a bit and look at the information it logs it in a much more logical manner, right? So look at this stack trace. It's one coherent set of info. It's not like 75 individual lines with a timestamp that you have to somehow figure out how the heck do I sort it. So if you're wondering what's that app logs table about, it's about us doing sort of the common sense formatting so that you can just come in here and say, oh, okay, right, one of the developers set this up and they just triggered a divide by zero exception. You can see they used, right, this pet clinic sample app, and it went ahead and crashed the app. And so because we had the logging hooked up and the alert hooked up, we're able to get the nicely formatted info about the exception, what type was it, where did it, when did it occur, where did it occur, and it gives me a better idea to be able to debug what's going on with my app. So again, I know that's a super quick run through, but I think probably more than anything else for now, that's probably the biggest thing by far on the platform, and frankly, not just for Linux, but for Windows, that we've started to build out the integration into log analytics and everything you can do downstream with that. So okay, let's wrap things up. Just real quickly, reiterating PV2, definitely the recommended SKU for folks to use on App Service. For GitHub, if you haven't played around with Actions, go ahead and check over on GitHub periodically because they continue to iterate on the preview and work on it. And then also with us on our blog, take a look because, again, we're going to continue to build out that integration, smooth out some of the rough edges. And like I said, I expect in the coming months, we'll elevate it to a first-class option inside of our deployment center and also with our command line. Hopefully for a lot of you, the managed certificates already gets you up and running. Like I said, if nothing else for dev test. You can issue as many certs as you need as long as you own the domains and you don't have to worry about paying for that anymore. And then again, we rounded out the talk going through all the new powerful options we've got with the text-based logging on the log integration. So once again, thank you everyone for attending. The session list is there for posterity since I think we're coming to the end of the conference. If folks happen to have any questions, certainly I'll hang out here afterwards. But once again, thanks for coming to the talk and enjoy the rest of the day.